Now here are those radioactive isotopes that has medicinal properties. The main thing related to radioactivity is it is for any this kind of troison. This is the super trick that is. Hey everyone, welcome back to our channel. This is our lecture 12th of covering chemistry. Now this is the last chapter of chemistry, that is nuclear chemistry, or you can understand it by radioactivity. A nucleus can be represented by zxa, where x is the name of the element and z is atomic number, which equals to the number of proton and electron in an element, and a equals number of mass. Isotopes. Isotopic element or isotopes are those elements that share same number of protons, that is their atomic number is same, that is z is same. What is radioactivity? Radioactivity is continuous spontaneous emission of radiation by unstable isotope. This spontaneous emission are of alpha particles, beta particles and gamma rays. The main thing about radioactivity is it is only shown by heavy nucleus, that is those elements that has mass number greater than 206. For example, uranium 238 atom, thorium 234 atom, radium 226 atom. Phenomenon of radioactivity was first discovered by H. Becquerel in 1896 AD. Now let us understand about three radioactive emissions. First one is alpha particles. It is helium nucleus which have charge 2 electron and mass 4 mu. It has no any electron. If an element goes alpha particle emission, their atomic number is decreased by 2 units and mass number is decreased by 4 units. In alpha decay, the ratio of neutron is to proton increases. Particle, it is either electron or positron. If an element goes beta particle emission, their atomic number increases by 1 unit and mass number remains same. In beta decay, neutron is to proton ratio decreases as the proton is increased by 1 unit and neutron remains the same. What's gamma ray? Gamma ray is the electromagnetic radiation decayed from nucleus after going radioactive decay. The ionizing and penetrating power of alpha beta gamma ray is ionizing power decreases from left to right and penetrating power increases from right to right. Now the most important portion is radioactive decay equation, or also known by radioactive law, which simply states that the rate of disintegration decay of radioactive sample at any instant of time is directly proportional to number of original atoms present at half-life. That is, dN by dt is directly proportional to n. N is the number of atoms present at that t time. After changing it into equal form, we get dN by dt equals negative of lambda times n. Negative sign shows that the number of atoms is decreasing constantly, and the lambda is decay or a disintegration constant, which only depends upon the nature of material and it is not affecting in vacuum. If we integrate this equation from 0 to 2 times, the original number of atoms was n naught. Now it is only n left. We get n equals n naught e raised to power minus lambda times of t, where it's showing that the number of atom will go exponential decay. T half equals 0.693 by lambda. What is T half? Half-life is known to be T half. There are three most important unit of radioactivity, that is 1 becquerel equals 1 disintegration per second, 1 Rutherford equals 10 raised to power 6 disintegration per second, 1 Curie equals 3.7 into 10 raised to power 10 disintegration per second. The half-life of radioactive material is 50 minutes. Then the time interval between 40% and 60% decay is. For any this kind of troison, this is the super trick, that is time interval is given by log of n1 divided by n2 divided by lambda. What is lambda? 0.693 divided by t half. By substituting the value of n1, that is 0.6 or 60%, n2 is 0.4 or 40%, we get 29 minutes. Radiocarbon dating is a technique to determine the age of archaeological material, that might be fossils, bones, etc. Radiocarbon dating is also known as 14C method, that is, it is based upon carbon-14 isotopes which have half-life of 5730 years. At heavy water, that is D2O, is used at nuclear plant as coolant and is moderator of nucleus. Now here are those radioactive isotopes that has medicinal properties. Cesium-99m is used in medical imaging, examples bone scans, cardiac scans, etc. It is divided by Tc-99. Gallium-67 isotope is used in detection of infection, inflammation, etc. Cobalt-60 is used in cancer treatment. Radium-24 is used as radio tracers that detect blockage in bloodstream and clotting of blood. Here are two radioisotopes of iodine, that is iodine 131 and 123. 123 is used in thyroid scans, whereas 131 is used in thyroid cancer treatment. Hydrogen bomb is based upon the principle of nuclear fusion, whereas atomic bomb is present on the principle of nuclear fission. If Na goes beta decay, it produces magnesium. During beta decay, a neutron in the nucleus decays, emitting an electron. Binding energy of helium is 0 electron volt. That's all it for today. You can find these notes from our Telegram channel and our Pinterest page.